Everyone, and welcome to another tutorial of Altium Designer Basics. And in this video we're gonna continue our work with the third part of geometry, and we're gonna make layout for real boards that are going to fit into a box. So to start with this, I'm gonna show you the drawings of a particular enclosure or box that you may come across while designing with Altium Designer. And in such a case, you need to, when you're choosing a box or enclosure that is already manufactured, then you get a file like this from the manufacturer website, which gives you all the dimensions that you need to design your board. As you see, it gives you the internal dimensions and the external dimensions. So I'm going to start with this box because this is very simplistic compared to some boxes that have curves and special shapes. So we'll start with this one. So to make this in PCB, we open a PCB file. It doesn't have to be in a project. So while it's opening, I'm going to have a look here. As you see, we have place for 4 holes, and this is important for mechanical strength of your board in the box, because if you don't fit them, it's probable that the box will move even though you fit them here in this margin. So now that we have the board here, we start by selecting by placing these. As you see, this is an M3 hole, so the hole diameter is suitable for 3mm screws. So I'm gonna create a 3mm hole here by placing a pad, and if I press tab, I can name it with H as a hole, and if I press Q once again to go to millimeters, now I can, again in the properties window, as you see. Okay, so here I want to make a hole of 3mm, but we make it a bit bigger, like 3.2, so that your screw can easily go through. And we create something like 6 times 6. So when you place the screw, it will not go directly in contact with your PCBs, but it will be here. And if we make this hole with EOS, the reference of our board for now, we see that the distance between 2 holes are 50 from this side and 37mm from this side. So all we have to do is copy this one, and then I press properties again. The distance should be 50, so I come here, I change the X to 50, so it goes to the position of 50. Now I want another one which is 37, so I put it here. I open the properties window, and here, as you see, the X should be 0 this time because they need to be aligned, as you see, and this one should be minus 37. So now we don't need to do these things again. We can copy from here and paste here, so we have the same dimension. And now to test, by pressing RM, we can measure the distance from here to here. Oh, sorry. RM. So from the center of this to the center of this one, and as a result I get 50 and 37 distance, as you see here. Now you might ask why I first placed the holes, because if you consider this distance from exactly the center of the enclosure, then we can use actually now this point, find this point, because it's exactly in the center of the triangle, the rectangle that these holes are making. So by using this reference, by changing the reference here, we can create these lines, and we know that, for example, it's 78.6 divided by 2 from both sides. So let's see how it works. Now I place another one like this, and I put it by AT. This is one method that you can do this. AT and AD, it becomes in center from here. Now because it's 37 divided by 2 is 18.5. So if I now make this minus, no, sorry, 25, it should be minus the y minus 16.5. It goes exactly to the center. You can also check it. Again. Okay, it's not exactly in the center because like it's, I mean, this line cannot cross it because it's not a square, it's a rectangle. Anyway, but if you measure the distance from here to here and from here to here, then they should be the same, but it seems they're not. So if I do an alignment, now it's in the center. Yeah, I forgot to align it between these two. So, and I did this by selecting all and Control Shift V. They will be aligned in a vertical order. So now we can again measure to see if it's exactly in the center. Yeah, this time it's exactly in the center, and we can continue with creating the borders. You should take care that in the case of this box, as you see, actually you should not make it bigger than the internal dimensions, otherwise it will not fit inside the box. So as the width point of view, it should be maximum 46.63, and we make it a bit even bit smaller, so we make it 46.6 or maybe 0.5. So if we divide this by 2, it's gonna get us 23.25. 13, sorry, no, 23.25. So I create a line here, and be careful, we need to place it in the cube out. So and it's not in the keep out layer, so I first press L, turn on all these unused off. So I just turn the ones that I need to be on, like the multi-layer and keep out layer. That's it. So now if I go into the keep out layer and press keep out track, I can draw in both directions. Don't need to draw again. I can copy paste it from the center like this. Okay, so now this line is going to be used as the half of our width, and this line is going to be as the half of our length. So going back to the data sheet, we see that we need 23.5. So it should be 23.5. So it's half of it. Sorry, 23.25. And we make a copy from this side and we put it here. Now we just need to move them to the right as half of the length, which we'll consider from this line. As you see, it's inside the box. So 83.6, let's say 0.5, So it's gonna be, let's calculate, 83.5 divided by 2, it's 4175. So we need to move right 4575. So this is going to be over x. Oh. But don't forget that we first need to set the origin back here. Now we move them, if you see their x, so 41.75. 41.75. I copy it also and also paste it here. Oops. So as you see, they move to the right place. Now for making the other side, we don't actually need to do this. We can use this idea of symmetry that we explained in the previous videos and go to the other side. So this is exactly what we get here. So we have these two lines now, and all we have to do is connecting, let me close the calculator, is to close our line. We also don't need to do this. We just have to draw a line in the keep out track and connect them here. And again, using the symmetry, I can put it here. Now that's what we get if I press tab and DST. This is going to be our PCB. And these actually borders are very thick this time, so we'll make them 10 or maybe 15 is better. So this is at the end our PCB. We don't need the center hole because as you see, we just need these holes and spaces. Also, there's something that you need to keep in mind when you're designing a circuit for this board, that when you put things inside it, as you see here, you should be careful how tall there will be, or what is actually the height of your circuit. Because if in some areas like here you place some components that are tall, like big relays, something like that, then you'll not be able to close the lid. So always also consider this when you're designing. So if you have a tall component, it should be, as you see here, so that you don't have a problem. The maximum height in this case here is 20 millimeters. So everything which is below 20 millimeter will fit without a problem in an entire box. But if it's more than 20 millimeter, you should bring it here. If it's more than 39, you should bring it here. And if it's more than 47, it will not fit. So you need to be careful. It's not just about the back of the box, but also about the front of the box that you need to take care of. So I'm going to continue with another box, which is a bit more complicated, but I will put the link to this, I will put this PCB also in the description of the video. Before I start creating the new box, I would like to show you a website, which as an example, this website called China Mold. And the first option that you have when you want to design a PCB and you need a box is using the available boxes on the market, because creating a custom box is expensive. And if you have this option and this possibility that you choose an already available box, then you should do it. And this is an example of housing or enclosure company. They make enclosures for different, and you can find many of them on the internet for different kind of boxes. For example, waterproof boxes, sensor housing, like whatever thing that you might be interested, like aluminum casting and inverters. And so they have already made a lot of kind of inverters for different applications. Most of the times you don't even need to make a new box because they are already there, so you just need to contact them and see what's the price. And you can also find many of these similar boxes also in websites like AliExpress or Amazon. And I'm gonna put the link of some of the boxes for you in the description. So then usually these boxes have a kind of data sheet that you can use in your project. Let's say we want to take this one. Sometimes they don't have it maybe on the website, so you need to contact the manufacturer and ask them to see if they have all the information you need. So the next box that I have in mind for creating the PCB is actually a bit complicated. This can be used for a modular system. As you see, there are a couple of cards that can be installed. But I'm just going to create a backplane here. And the backplane is where you're going to actually mount all these cards. So if you see the backplane, it's quite straightforward. And all you need to do is just create these holes and the distance between them. I don't see anything showing about actually these holes, but I just take them as M3, and once this is what you can do in practice. Once you have the box in your hand, you can measure and see what actually the size of these holes are. So for now we can make them as what we did in the previous box. So I create a new PCB file. And I import one of the holes here because we have the same thing. If I go back here, I see the first distance between them is 69.5 and then 70. So if I copy it here, place it here, and if I press AT, align top, setting the first one to 0, then all I need to do is making the distance here, of course in millimeters, because we have the distance from in millimeters, to 69.5. So this is where the first hole should go. And now because we have the 70, we either have to add it to this one and then use it from this reference, or we can change the reference to here. So I change the reference to here, it's easier. Now align bottom because it's above, so you can use AT to align them from top to bottom, or align top, AT, top to bottom to top. And now we make the distance of this one to 70, and the next one, if we consider here, it's 110. So the next hole can go to, if we align them here, properties, 110. And we have the same, exactly the same holes, but with a different distance of 65 millimeters. So I start from here, I align them to the right, and if I set the distance now, because they're all on the same X, yeah, this one is also in 0. Sorry, in the same Y actually. So all I have to do is to make the Y to 65. So this is 65. And also I do the same thing here. I align this one to the last hole, and then I make the distance of this one also 65. So now we have 2 holes remaining here, And what we're gonna do is copy from here and paste here, and also this one we can copy from here. Be careful of this green circle to be exactly at the center point, and here we get all our holes. Now we have the holes, and using the same method that we did before, we can realize that it's 32.5 here from this. If you consider this point, I want to find this point. This is 32.5 from this side, and from this side it's 40 to 35, which is, no, it's not exactly the same value, so you should be careful. We want to compute the distance, the center. So from top to bottom it's 65 divided by 2, which is 20, which is 32.5. But from the center here, it is the center of our board and not the center of our holes. If I'm seeing it the right way, yeah, because the holes are not exactly aligned with the center. So sometimes it's not directly shown, so it's a bit tricky. You should be careful. As you see, the distance from here is down to here is 157, and if you want to find the distance from here to here, which is actually we're looking for, then you need to subtract 157 by 65 and divide it by 2, and you get the distance from here to here and here to here. Then also by having this distance, you can realize where actually you should put the 0 point of your circuit. But there is another point, and it is that your 0 point of the circuit does not actually start from here. As you see, this part of the circuit is not used, and it's just for placing some screws for mounting them on a panel or something. So the actual distance that we can have is from here, from inside, to place our PCB. So we should also be careful about these points. And if you measure the distance here, it's 300. So the length will be around 300, or a bit smaller also, like 299 I would place. And also here the height will be exactly 157 or 158.9. But the point is that you need to place them in the right, place the holes in the right place. So what I'm gonna do now, I will create a line with my keep out here regarding the holes for now. So I go to, again, I need to configure the layers. So I just turn on the layers that I need, not this one. I need the keep out and multi-layer. So I just want to place a track in the keep out layer like this, and I place this point as 0. So what I'm going to have will be 157, or a bit smaller, as I said, 1 millimeter less, 156, and also 299. So I make the length 299 and also 156. So now we have this, which I can use again the symmetry and mirror from one part, copy, and paste in the other place. So I just need to rotate it with space a bit, and then I put it in the right place. So if I press tab to select all the keep outs and then DSD, then it will be our PCB how it should be, but now we don't need actually where these should go. But it's quite easy. We know that we have the distance of 55, so I put another one. I remove all these, put them out of the way now. Let's say I put them here. So I copy one of them, and considering from this point, it will be, let's see, which will be less than 55. So this distance from here to here, and we don't know how it is. So what we can do is creating a test margin for ourselves, considering the entire length and the entire width. So if I extend this, then what I do here is I create a new line from the center of this line, place track, so this is another line, and I make it double the size of 340 1 divided by 2. So 340 is 170 and a half. So if it's 170 and a half, but again we need to put this exactly in the center. So I'm gonna select it here by Control C. Control X is better, so I remove it altogether and put it here in the center. So now if I create the same thing and just rotate it 180 degrees, so let's make sure it's at the center, and I get this. So now I can say where exactly the hole is gonna be, but we don't really want this to be there. So what we can do is maybe we can replace it with another layer. So for example, we have this other mechanical layers I think that we can add. I don't know here why they're not. Okay, there's usually more than one mechanical layer, but we don't actually need it. So again, if I copy it from here, I can paste it. I want it to be a different color so that it is better to see. So we can make it maybe not the keep out, but let's forget about it for now. We could make it top overlay, then it would be better. So now I stay with the keep out that we used. So I connect it from here to here. Zoom to make sure it's okay. And then I copy from here. Oh, what happened? And put it here. When you lose your PCB, something like this, then if you press VF, you can find it pretty easily. So now you know that the distance from here on, from if I set this place as the origin, the X is 55. So I make X 55, but I'm not sure about the Y. So if I open the calculator once again and 150, we have 157 minus 100, minus 65 divided by 2 is 46. So the distance from here to here is 46. Again, 157 minus 65 divided by 2 is 46. So now y should be 46. So this is originally where your hardware will be. Your hole will be. What you can do now is select all these holes, and since they are in the correct distance with each other, we can place all of them here and delete one of the holes. And that's it. As you see, the distance from the left side is less than the distance from the right side, almost half. And this is what seems that we also have here, but I'm a bit suspicious about it since the distance seems to be much bigger in here. So let's do a bit of checking. Maybe it's just a drawing, so it's 40. The distance from here to here is 46 and 55. The distance from here to here is 65.9 and 9.5, and the distance from here to here by doing RM is 70, and it should be 65. And this is also 65. It seems to be okay. I believe the distance from here to this side is the entire distance of 341. 341 minus 40 minus 70 minus 69.5 and minus 55. So the distance here is of something like 106.5. So let's check it. The distance from here to here oh, it's 85. So something must be wrong. I think wait, no, yeah. We also consider this distance 300 to 341. I made this I will make this one also just 1 millimeter. It's not a big impact. So maybe there's something else wrong. Again, let's do the calculation. So 55 plus 69.5 plus 70 plus 40 is 234.5. And if we subtract this from 341, 1.6. So the distance from here, I think I measured from here, so the distance from here to here should be 1.65. exactly. It's 1.645, so it's just 0.05 millimeter away, and it's with good accuracy. Anyway, so this is what we get. Well, actually, your real PCB will not be exactly the same as I said, the entire outline. It's just the inside. So, and we made it 1 millimeter smaller. So at the end, you need to delete these lines that you used as just your guidelines, and here you have your PCB for the backplane of this enclosure. I hope you enjoyed this video, and I hope it was useful. Thanks for watching, and don't forget to subscribe in my channel, and I will see you next time.